In today's video, I asked ChatGPT 3 questions that I could solve algebraically. Question 1, question 2, and question 3. Let's have a look at the first question. And the first thing that you do notice is that it's a trinomial. So ChatGPT has given us the trinomial to solve. And when we see a trinomial, what's the first thing we do? We look at the quadratic formula. And the quadratic formula is as follows. We have minus b plus minus square root b squared minus 4ac over 2a. First and foremost, we are going to have a look at the coefficients. All right. So for a, we look at the first coefficient of x squared, or we look at the coefficient of x squared. The coefficient of x squared is 2. We know the value of a. Now we need to find the value of b, and the value of b is simply the coefficient of x, and the coefficient of x is negative 5, not 5, negative 5. And to find c, we simply look at the constant value at the end, right there. To find c, we know that that is the constant value, which is plus 3. Right, let's go ahead and substitute into the quadratic formula for our two possible answers. So as follows, we know that a is equal to 2, b is equal to negative 5, and c is equal to plus 3. All right, or 3. So what we do now is we substitute into the quadratic formula, and we will get our two possible answers. Now that we found our values for a, b, and c, we are simply going to substitute into the quadratic formula and get our two possible answers. So an important note as well is that when you do substitute, you substitute in brackets. For example, when we are substituting into the quadratic formula, we have minus, open brackets, negative 5 is our b value, it goes in there, and plus minus square root, we have negative 5 again, squared, minus 4, we are substituting a in there, a is 2, we are substituting c, c is 3, all of that over 2 brackets, a is 2 as well, and we know that x is equal to that over there. Okay, and we have two possible answers. First, we're going to use the plus in our calculator, and then we're going to use the negative. So we will have two possible answers. Putting that in our calculators, we get x equals 3 over 2, or x is equal to 1. The first trinomial is the first question by ChatGPT. It's quite simple, as long as you know the quadratic formula. But what if you do not know the quadratic formula? I will show you how to do that without the quadratic formula now. Firstly, in this method, I'm going to draw an x over here. And for this method, you might need a bit more practice. It might be a bit more difficult. Comment down below your method. But for this method, we're going to put two values here, which give us the first term, and that is 2x and x. So when 2x multiplies with x, it gives us the first term in the trinomial. Okay. Then we're going to choose the factors of 3, two numbers that multiply to give 3 on the side, and we want, when they come together, to give us the middle term. For example, we want them to come together to give us the middle term. If I have 3 over there and 1 over there, okay, we see that the middle term is negative 5. So if I add a negative 3 over here, right? I know that when I multiply across, I get 3x. And when I multiply across on this side, that is 2x. Negative 3x and positive 2x won't give me negative 5x. Also, negative 3 times 1 won't give me positive 3, so I need to change the sign over there. Now, when I multiply across, I get negative 2x, and multiply across like this, I get negative 3x. Okay, and that negative 2x, negative 3x gives me negative 5x. When I multiply here, negative 3 times negative 1 gives us plus 3, because a negative times a negative gives us a positive value. Now we take the top part and we let it equal to 0, and the bottom part we let it equal to 0. Now we have two equations. We have 2x minus 3 is equal to 0, or x minus 1 is equal to 0. And we solve for x from these two equations. We take the 3 over and we divide by 2. We get x equals 3 over 2, or we take the 1 over and we get x is equal to positive 1. As you can see, both answers are the same as the quadratic formula. This method may be a bit tricky, but comment down below your method. Tell us how you would solve this without the quadratic formula. In our second question, it seems as if we have two equations. There are two ways you can solve this. You can solve this via elimination, or you could solve this via substitution. Over here, we are going to use the elimination method, as it is much simpler way over here. So firstly, I'm going to try to make my coefficients of one of my variables the same. And as you can see, if I multiply this entire equation by 2, the variable for y would be 2. Okay, so if I go ahead and multiply by 2, my second equation is now 8x plus 2 equals to 14. Right? Now I can simply put my two equations underneath each other. Using the elimination method, as soon as your variables are the same, you can put them underneath each other. You can either subtract them or add the two equations to each other to eliminate the variable. That depends, to eliminate one of the variables. That obviously depends on the sign of the variable you're trying to eliminate. For example, minus 2 plus 2 gives us 0, or minus 2y plus 2y gives us 0, therefore eliminating the y variable. Okay, so we have 3x plus 8x gives us 11x equals to 4 plus 14 gives us 18. Okay, and to solve for x over here, we're going to divide by 11, and we have x equals to 18 over 11. Now that we have an x value, we can substitute it back into any of the two equations. We chose the second equation simply because the coefficient of y is 1. It's more simpler to work with. So now we substitute. We have 4, 18 over 11. We are substituting the x value in there, plus y equals to 7. We're going to multiply the 4 into there. We know that 4 is 4 over 1. So we're going to multiply the numerators and the denominators. The denominator does not change because 11 times 1. But the numerators, 4 times 11 gives us 72 over 11 plus y equals to 7. Then we take 72 over 11 to the other side, and we get y is equal to 5 over 11. So we have our two answers. We have x is equal to 18 over 11 or 5 over 11. I think there could have been more difficult ones when there is a trinomial or a quadratic equation in there. But nevertheless, we've done it. Question 2, easy. Question 3 seems a bit more daunting if we couldn't solve by inspection. When I look at this, I'm going to first try to solve by inspection. All right. If I substitute 2 in here, that's 2 plus 1, that's 3. 2 to the power of 3 is 8. And then 8 times 2 is 16. Doesn't work. If I try to put 3 in here, 3 plus 1 is 4. 2 to the power of 4, which is 16 on the left hand side. And on the right hand side, if I substitute 3, I get 24. So we get 16 over here and 24. They are not equal. If I substitute 4, however, 4 plus 1 is 5, right? And 2 to the power of 5 is 32. And 8 times 5 is 32 as well. So we know that x is equal to 4. But what if there was a different way to solve this equation? What if you could not solve by inspection? If you made it this far, like, comment anything that you would have done differently. Or anyways, first and foremost, when we have an exponent, when we have an unknown value in the exponent, the first thing we're going to do is that we're going to make sure that the bases are the same. So we have 2x plus 1, 2. We're going to transform it and factorize it. Okay, and we know that it can be 2 to the power of 3. 2 times 2 is 4, times 2 is 8. Okay, multiplied by x. However, this base is not 2, so you cannot say x plus 1 is equal to 3. You cannot say that. Okay, so there is no way that we can let all the bases be 2. That's impossible. So we need to bring the exponent down, so we can take the natural logarithm of both sides. So you're going to take ln 2x plus 1 equals to ln 2 to the power of 3 dot x. We know that the logarithm rules state that you can have ln 2 to the power of 3 plus ln x. We know the logarithm rules that state that ln a to the b is equal to b ln a. So we can take the exponent and bring it down. So we can take the x plus 1 in brackets over here, x plus 1, bring it down to the base, and then have ln of 2 equals to ln 2 to the power of 3 plus ln of x. We can also take the 3 and have it over here. Since we know that the logarithm rule over here, the exponent goes over there in front as a coefficient. Now we're going to divide by ln of 2. We're going to divide by ln of 2. Okay, as we can see, the ln will cancel over here, cancel over there. Now we have this equation over here. We're going to take the 3 over. We're going to have 1. We're taking the 3 over. It's a plus 3. It's going to change to a negative 3. So we have 1 minus 3. We end up with minus 2. 1 minus 3 is minus 2 equals to ln of x over ln of 2. Now we're going to multiply the right hand side and the left hand side by ln of 2. Multiply by ln of 2 on the side and multiply by ln of 2. When you multiply more than one term on the left hand side or the right hand side, please add brackets. Okay, so when you do multiply, it is multiplied to every other term. Okay, so we end up with ln 2x minus 2 is equal to ln of x. So to solve this, we can solve it graphically. We can draw first and foremost the graph of ln 2x minus 2, and we can draw the graph of ln x. Okay, and we can simply substitute values into x. We're going to solve this graphically, and we know that x will be the point of intersection. That's when we will know what the value of x is. Okay, so first we're going to draw the basic ln graph. We know that the domain for the ln graph is that x is bigger than 0, and the range is that it's all values from positive infinity to negative infinity. Okay, to draw a basic log graph, all you're going to do is you're going to choose a set of x values. Okay, and we know that the domain of a basic log graph is that x is bigger than 0. So we can choose the following numbers. We can choose x is equal to 0.5, x is equal to 1, x is equal to 2, and so forth. We have all of x and y values that correspond for the graph of ln of x. So we have y is equal to negative 0.69 when x is 0.5, and so on. Now we simply plot these values onto our graph. Next, since we know that the graph of ln of x does not exist on the left-hand side of the x-axis, we're not going to choose any negative values. Of ln of x does not exist on the left-hand side of the x-axis where x is equal to, where x is negative value. We're not going to choose any negative x values for this graph. So we're going to start with 0 and so forth. Now we have our corresponding values for x and y for our first graph, and we're going to substitute and graph these values onto our graph over there. We just need to fix the rounding error over here. It's actually 1.39, and as we can see that this ln graph is actually a straight line, okay, with ln of 2 being the gradient of the straight line graph. So we actually have 2 points of intersection. Okay, the first one we can see with our set of values is when x is equal to 4. Okay, and we will need a graphical calculator to find this point of intersection as well, which is 0.31 if you use the graphical calculator. Okay, so we know that x is equal to 4 or x is equal to 0.31. Let me know if you enjoyed this series where I tackle ChatGPT's questions. Like, comment, subscribe. Let me know anything that you think I should do next, or anything that I missed in this video. If you enjoyed it and you stayed up until the end, thank you.